Hi, anybody here? No, not yet. All right. Well, as I wait for folks to come on, I'm going to finish my setup here. I tell you, going live is not a simple thing, people. It's not. But I am set up to the best of my ability. And I hope that you enjoy our little half hour together. Have a couple of activities planned as promised. And we're live. Hi, my name is Stephanie E. Farmer. I'm the founder of Triple F Empowerment Inc. I am the Miss Steph in Miss Steph Science Club. And it is my honor and privilege to work with each of my students every day. I do really hope that several of you come on and join me for our very, very first live, amazing, our very first live science class. So I'm going to turn my volume up. I have no idea whether or not me turning my volume up helps you hear me, but I'm just going to make sure that that's in place. So it looks like I've got at least one person on. Hi, whoever you are, thank you so much. I hope that you will put a comment on, we've got two people. What? Come on, people, we got a science class. Once we get one more person, we have a whole entire class. Come on. Aren't y'all excited? So once again, as I was saying, I'm Stephanie Farmer. I'm the founder of Triple F Empowerment Inc. And Triple F Empowerment Inc. is the nonprofit that operates Miss Steph Science Club. Thank you so much for joining us in our live venue. Yes, for those of you who have not been here, this is the original Science Club location, which is my apartment. And I'm here in my living room doing some science with you. I have some material set up to really have a great time with you. At the end, towards the end, I'll make sure that I write, because some of my learners are visual learners. Some of us are, just need to hear about it, whatever and what have you. But at the end, I'll make sure that I write down the three things that I'm covering. And those three things are, once again, we're going to do a spaghetti structure, which literally just takes your imagination and some dried spaghetti and some marshmallows. I have the jumbo marshmallows here with me today because, to be honest, I prefer the jumbo marshmallows when I do this activity. Some people may prefer the miniature ones. Some people also may prefer to use gumdrops, even though these days it's really hard to get the gumdrops. And that's pretty much it on that. And then I have the dancing milk activity here. Now, for the dancing milk activity, you do need whole milk. Whole milk is very important. You need a high fat content for that activity to work. And I've got food coloring, any kind of food coloring will work. And I have some cotton swabs. They don't have to be Q-tips. I've got cotton swabs here in the beaker. Doesn't the beaker look fun on the little video? Yes, I know. All right, cotton swabs in a beaker and some soap. So let's get into it. We've got a couple of people, and I'm definitely hoping more people will join us, but such is life. All right, so when we're working on a structure, first of all, a structure, you need to have some type of plan, right? Because you're looking at being an engineer. You're looking at building something in a way that meets some type of guideline, some type of standard. And once again, we're going to use our spaghetti. I have broken some of the spaghetti. You are probably hearing, I have no idea what you can hear. But again, this is live, so such is life. You may be hearing some things in the background, but hopefully you can hear me. I'm going to talk louder so that my voice is louder than all the things that you're hearing from my window. Once again, our materials are dried spaghetti. I broke some, and I'll break some more later. And the jumbo marshmallow, you can tell how big that marshmallow is. And a lot of the times my students will ask me, can we eat the marshmallows? No, I'm still going to say no, especially with all this health stuff that's going on. Okay, you might be a child, but you probably know that there's a few things going on right now. Okay, and aren't we washing our hands more and more? And so, no, we're not going to eat the marshmallow after we play with it. Thanks. All right, now let's go ahead and move on. So our structure, what's the parameters that I'm going to set for our structure? Sometimes I will give you all a certain height or a certain kind of design that I want you to be able to meet. And sometimes I'll just say, go for it, use your imagination. So I think that's what we should do today. Now, before we do that, though, we need to consider, number one, what is the strongest shape? And as some of you may know, especially those of my regular science clubbers, you know that the strongest shape is a triangle, right? This is our triangle. And I'm going to put this up close so that you can see. I actually have three on each side there. And then let's compare it to our square. Right? Do you see how flimsy the square is? I have to hold it really gently to make sure I don't break it, right? So when we're looking at building a structure, if we want it to be strong, even though I'm using my imagination, I want it to be a strong structure. I'm going to base my structure on a triangle. So I want to have mostly triangles, or at least form triangles, while I'm working. So I'm going to put this down a little bit so that you can see more of what I have here. This is my little rolly little part situation that I've got going on. And once again, I've got my base. I'll show you very quickly. Let's build another one of these, right? Didn't I say that I had 3 per? So I'm going to take my 3. Shout out to whoever just joined us and whomever click the like, right? So I'm going to take my 3, put it into my marshmallow, go here again, and then now I need another 3 because I'm trying to make sure that my base is very strong. And truth be told, done properly, we can turn this into an actual top to the structure. So I'm going to push. Notice I'm pushing kind of slowly so that I don't puncture, like it's not going through the end of the marshmallow. All right. Then I'm grabbing another 3 sticks. And yes, you can break your sticks. You're creating this. This is something that you're making on your own, and it's exciting to you, right? So once again, this is so much stronger than my flimsy little square. See, my square is moving around. Now I could add the square to this structure, this shape later to build on top of my structure, but I've decided that I'm not going to do that. I'm actually going to take these here and let's see what I can do to put them together. All right. So once again, I've got 2 of these, and I'm going to give you a few moments to notice how many pieces I need, right, as an engine built. I'll put this here on the floor a little bit. And once again, some of you are just now joining us. Shout out, love it. I'm so excited. We have a class, yay. Okay, and I'm making sure that I'm gonna break my sticks, right? You notice what I did just now. It's very gentle. My stick, nothing flew across the room. I'm just gonna got my nails there, and I'm just some pressure, okay? And I'm making my sticks about half of the length, because I also, as an engineer, want to make sure that my structure is balanced, okay? And today's parameters, for those of you who are just now joining us, today's parameters is to use my imagination. All right. And so if you're doing this with me, I want to encourage you to use your imagination. Your structure, really, to be honest, shouldn't look like mine. And it should look a little different because you're you and you're different from me. And I actually think that would be a great way for us to interact once I start to share this. I'll share after this video is done. I'll share it on Facebook and all that kind of great stuff. And maybe you could comment with a picture of your structure. And you can comment with some of the challenges that you noticed while you're trying to make your structure. All right, so once again, triangles are the strongest shape. And so that's why I'm basing my structure on triangles, right? So you notice I'm getting another triangle here, okay? And I'm putting in 3 because I want my structure to be balanced. I've been using 3s here. Now let's see if we can turn this into a top, right? So notice I can hold this. I can hold this. And it's not wobbling. Whereas remember, our square, it wobbles. The square is not stable. The square is not where we want to base our structure on. We want to base our structure on triangles. Now you might say, but Miss Steph, if it's my imagination, it's my structure, what if I wanted to build a square base structure? So you can do a square base. But what you would want to do is try to somehow incorporate a triangle in there at some point. Now, did you see that? Did you see my structure kind of tilt a little bit? So I have a choice, right? I'm using my imagination. It's my structure. I have choices. I can let it continue to tilt and have that be a part of my structure. I've actually seen some great structures in the past where I have, like, some of my students have let it tilt and then they kind of keep growing and it turns. Or I can give it some pressure to make sure it goes straight. So what I'm going to do, I'll put this here and then now I'm going to break it. You notice what I did there was actually a form of measurement, right? I wanted to make sure that it fits. All right, and so should I just leave it with just the one side reinforced? Everybody say reinforce. You're not saying it. I know you're not. I can tell. Everyone say reinforce. Okay, fine. You said it, I think. All right. So to make sure that it's the right size, I should measure. Look, that one I didn't measure, and it's too short. Oh, naughty Miss Stephanie. All right, so I'm going to take this out. Okay. And let's try this again. Let's go ahead and measure. If I measure it, I know it will be long enough. Take this here. Once again, I'm reinforcing. I'm adding some more support. I'm making it so that my structure does not twist. Now, isn't this amazing? I've only added reinforcement to 2 of the sides and my structure has stopped twisting. But to be sure that it's as strong as possible, you want to add reinforcement on all of the sides. Right? So I'm pushing gently into that bottom marshmallow. I'm measuring, breaking at the place that I need to break at, and now I've reinforced. And you might be wondering, oh, we have a 5th person. Child, we have a whole class. I'm so excited. What happened to the 5th person? You went away? No. Okay, seriously. So you'll notice I only reinforced with one of the spaghetti sticks. That being said, I could keep going to capacity of the marshmallow. Okay, so I'm really rolling excessively with these vocabulary words, but vocabulary is important, okay? And it's so important to me that you learn the accurate words to use to be able to describe your structures, to be able to talk about why you did what you did when you're building something, right? Because when we're doing STEAM, we are using our imagination, but we're also using our science knowledge to be able to meet our challenge, okay? And that's what we do as engineers on a regular basis. We're meeting challenges. And so, yes, I was saying I only did 1 stick to reinforce, but I could do multiple sticks based on the capacity of the marshmallow. So kind of think this through. Now you see, okay, you may have not been able to think it through, but now you can see for yourself why I prefer the larger marshmallows for this activity. It's more entertaining to me. And for some of the adults that might be watching, this is a great activity that you can do with any of your children. As long as they're old enough to push the marshmallow, and I've done this with kids 18 months old. Okay. And so you can play with this. And for my older students, for my middle schoolers, I definitely would want you to be trying to record the measurements. Look, I can turn this on different surfaces, right? You can record the measurements. You could also challenge yourself. Like I said, for my older students, for my 5th grade and up, you could challenge yourself to build a specific surface for it to be able to then set something on top of, or say, like, look, so this is kind of the one of its surfaces it doesn't really stand up on. Okay. So if I wanted it to be able to do that, I would need to then build things down this way. Okay. But let's take it back to its original. Once again, triangles are our strongest shape. If I'm pushing the reason that is that triangles can take pressure from any of its sides, and it will push back. You push back, right? But then this side of the triangle will exert an opposite force, and it'll still stay stable. So you'll notice the buildings, when buildings are going up, they're putting some type of triangle in there at some point. They don't just do all straight, all vertical, whatever those vertical supports. You definitely use some type of triangular support. All right, so we're about 16 minutes in. Once again, I'm Stephanie Farmer. I am the founder of Triple F Empowerment Inc., and I am the Miss Steph in Miss Steph Science Club. Triple F Empowerment Inc. is the nonprofit that operates Miss Steph Science Club. And we are here today because for various reasons, we're not able to gather in person. But that's okay, because we have technology and we can meet like so. Yes, people, I'm excited. Now, I'm going to put my structure away. Which I would recommend that you put yours away for a second while we do the next activity, and then you can pick this up. You see, you could be working on this for hours and hours. Spaghetti structures. And once again, we used marshmallows and some dried spaghetti. As far as whether or not you can use the cooked spaghetti, I'm going to let you figure that out and tell me. All right, then, ooh, we got some more people, child. Don't you know I'm excited? Yes! All righty then. For those of you who didn't know, I am more silly in person. You think this is silly? You think I'm hamming it up for YouTube? I'm actually this, like I said, I'm worse in person, especially with my students, because we have a great time. All right, so now we are moving on to the dancing milk. Remember, I told you the dancing milk, to use the milk, you might not want to do it right now with me. Maybe you want to watch it, which is totally fine. To do the dancing milk, you want to make sure that you have whole milk. Now, I'm going to pour. I have a plate. You can use a really sturdy plate. I've done plastic plates before. Today I'm using a real plate since I'm at home. It's like a real, ceramic, whatever plate. I've done plates that are like really like several layers of a paper plate. You can do that. And actually a paper plate for the adults that are in the room, which I do hope we have some adults with us. Hi guys. If you want to do a paper plate, you could do a paper plate, and then when you dump out the milk, you'll see an art activity that you could let dry and put that up as something that your child has created. So yes, I am aware I'm talking to all kinds of different people. So as you see, I'm pouring. Are we ready? We want to go ahead and move on already then. So we're doing our dancing milk. That's this particular activity. Now I'm going to tilt my camera down. Notice I'm pouring very slowly, and I will really, really reiterate, have to have whole milk. Now, we'll talk a little bit about what you would do if you didn't, or if you wanted to try multiple things. So we have, let's go ahead and do the activity. I'll show you, and then I'll put the camera back, and then we can talk about the science behind it as far as why this puppy works. This one is really fun. This is one of our science play activities that we use. And you see that we have, and you'll see in a second, if you haven't done this, why we call it science play, right? So I've got my Q-tips and soap. That's soaping here. You want a nice flat surface. And now let's think about what we want to do for our food coloring situation, how we want to set up and design our palette here. So you want to try your best not to move your milk back and forth once it's settled. So I have a Q-tip. I'm going to take it. I want to make sure that I have soap on the bottom. Now, some of my students like to kind of like move around and all that kind of stuff. Some you might want to place it like starting here. Place my Q-tip in the middle. Woo! What? Isn't that cool? So it's still moving. I hope that the camera is picking that up because it's a little hard for me to be able to see, but it's still moving, and you're going to get some kind of different colors that will come out. All right. So I'm going to take this, and I usually like to have some type of waste container available so that your already used ones go somewhere separate from your clean Q-tips, right? So we already did the middle. So let's see what happens if I do here. If I come over here, I'm starting to get some movement, right? Do you see some, what looks like movement? This works because fat reacts. Everybody say reacts. You didn't say it. I told you all about that. Reacts. Okay, fine. You said it that time. Fat reacts to surfactants. Okay, so there are surfactants. A surfactant is something that kind of helps fat and water-based molecules mix together. It helps us clean things that are oily surfaces. It helps us clean an oily surface. I'm going to move myself up a little bit like that. All right. It helps clean an oily surface with water, because if you just try to rinse something off, it's got oil on it, you just try to rinse it off with some water, child, that water by itself is not going to do it. It's not. You know why? Chemically speaking, it's like impossible. It just doesn't work that way. But when you have a surfactant, when you have a soap, you're able to rinse, okay, and you're able to wash something that has a fat layer with soap and water. That's why they say soap and water, right? Without both soap and water, it tends to be very hard to properly wash things. All right. Oh, we're losing our audience. Hello. Where are you going? Where are you going? You don't want to keep doing this? You're not going to talk? Listen to me and join me for the important part of the scientifically speaking. No, don't go. No. All righty. So now I'm just being silly, but that's life. Sometimes I can be a little bit silly. So as you can see, this is quite kind of hypnotizing a little bit. You can see why this is science play for our students. The children can sit and play with this for a really, really long time. It's quite fun. So once again, my dear loves, I'm talking to, you notice I go back and forth between speaking to the adults and speaking to the children in the space, just because I deeply believe that everybody should be respected and everybody should be spoken to on a level that they can understand and that they feel like they're part of the conversation. Once again, thank you for joining me for this adventure today. I will let you know if we'll be doing this again and how often we'll be doing this, but it was nice hanging out with you for a little afternoon. As promised, I'm going to write down on our list the things. It's probably backwards on your thing, but yeah, it will be okay. All right. So we just did the dancing milk activity. That was our second STEAM activity. And then scientifically speaking, is our campaign. And for more information about not only scientifically speaking, but how many children we interact with and just the different things that we're doing and how to get a hold of me to find out how to enroll your child in one of our various activities, as well as when I'll be doing my next little thing here. You can keep in contact with me by going to our website, tfempowerment.org. It's a little hard to write this way, by the way. And you can always send me an email at Miss Steph at tfempowerment.org. All right. So thank you for joining me today for our Science Club via live stream. I hope you have a wonderful rest of your weekend, and please feel free to ask questions and join us at one of our Saturday sessions and the various things that we've got going on coming up soon.